Number 3. The formula for kinetic energy is Ke is equal to 1/2 mv squared. Right? That's according to the fifth assumption of the kinetic molecular theory. It states that the velocity, right, the speed, the kinetic energy of a particular sample of gas is dependent on its temperature, right? That is the equation that represents that. But A reads, as long as temperature is constant, what happens to the kinetic energy of the colliding particles during an elastic collision? Well, if temperature is constant, that means there's no change in kinetic energy, meaning kinetic energy doesn't change, right? It doesn't increase or decrease. It has to stay the same. So if there is, in fact, a collision and then the speed of one particle is adjusted, what's happening there? Well, that means that the energy that was present in that moving particle must be transferred to something else. Right? The energy must be transferred between those colliding particles, right? That's what it means to be elastic. B, if two gases have the same temperature and share the same energy, right? Because at the same temperature, gases will have the same amount of kinetic energy, but have different molecular masses, right? So the value for Ke is the same, but the value for M is different. Which molecules will have a greater speed? Well, those with a lower molecular mass, right? So if kinetic energy is always the same, but one gas has a very large M value and the other one has a very small M value, the one that is going to result in the larger V must have the smaller M, right? I know one professor that I had was very, very fond of writing things in this way. Let's say kinetic energy equals 1/2 mv squared. And he would represent the hypothetical situation of this problem. Which molecules will have a greater speed? What he would do is he would actually write the letters large or small, depending on what the prompt said. This prompt, right, says, asks which molecules will have a greater speed. So if kinetic energy is the same, it doesn't change. We have 1/2, but this V is very large. In order to keep this relationship true, because Ke hasn't changed, but velocity is very big, in order to balance that out, mass must be very small. And he would write this on the board all the time. And it was very, very annoying at first. Very, very annoying at first. But it finally sank in, and it makes so much sense. It's very, very intuitive for me now. And I hope it can help you. Right? So those with a lower molecular mass, will, right, smaller m, will have a bigger velocity, a larger value for v.